Hi guys, welcome to the second module of Microprocessor Practicum made by Microprocessor and Intermixing Laboratory, which is commonly referred to as UPG Laboratory. In this module, we're gonna learn about Arduino, ADC, and PWM. Okay, let's get to the main part. So now we're gonna learn about Arduino. Arduino is a platform of open source physical computing. Arduino is not just a development tool, but a combination of sophisticated hardware, programming language, and integrated development environment, or IDE. IDE is a software that is very instrumental in writing programs, compiling into binary code, and uploading it into microcontroller memory. The Arduino IDE is a very sophisticated software written using Java. Arduino IDE consists of three: editor, compiler, and uploader. So there are various types of Arduino. The difference is the pin that can be used and the feature actually, the size of the memory and other features. The following are various types of Arduino that are often used, namely Uno, Due Milano, Leonardo, Mega 2560, Intel Galileo, Pro Micro IT, Nano R3, Mini AT Mega, Mega ADK, and Arduino Explorer. In Arduino, there are two types of pins. There are analog and digital. Digital pins have two values that can be written: high, which is symbol as 1, and low, which is symbol as 0. The logic of high is 5 volts sent to the pin either by microcontroller or from the component. Low means that the pin is 0 volt. Analog pins have different characteristics from digital pins. Information that can be written or read very wide. For example, for write values from 0 to 255 can be written 0 to 5 volt. As for read, values from 0 to 1023. 0 to 5 volt, which is increase of 0.005 volt, can be represented. So Arduino Uno can be activated via a USB connection or with an external power supply. The resource is selected automatically. External or non-USB resource can come from either an AC-DC adapter or a battery. The battery can be inserted in the ground and V-in header pins of the power connector. The board can operate on an external supply from 6 to 20 volt. The electric pins available are as follows: V-in input voltage to Arduino board when using external sources. GND is the ground pin, and I/O ref, this is the pin of the Arduino board, provides a reference voltage when the microcontroller operates. So for the memory, ATmega 328 has 32 KB with 0.5 KB used for the bootloader. ATmega 328 also has 2 KB of SROM and 1 KB of EEPROM, which can be read and written with a library or EEPROM library. And input-output, each of the 14 digital Uno pins can be used as input or output using the function pin mode, digital write, digital read. They operate at a voltage of 5 volt. In addition, some pins have special function. There are serial, USB to serial, extra interrupt, PWM, analog, LED, RF, and reset.
Next is ADC, or analog to digital converter. First process of ADC is sampling. Sampling is the process of taking a definite value or discrete in a continuous data at a certain point in time with a fixed period. Next one is quantization. Quantization is the process of grouping discrete data obtained in the first process into group of data. This is the process of quantization. Last one is encoding. Encoding is transform quantized data into digital form or in a binary value. Next one is pulse width modulation. Pulse width modulation in general, it is a way to manipulate the signal width it announced with pulse in a period to obtain a different average voltage. The slumber width modulation is obtained with the aid of a square wave in which the working cycle of the wave can be changed to obtain a varying output voltage, which is the average value of the wave. This is the formula of output voltage. Next one is PWM pin in Arduino. For PWM, pin that are marked with tilde, namely pin 3, 5, 6, 9, 10, and pin 11. If you want to use PWM on this pin, you can do it with the analog write command. PWM on Arduino work at a frequency of 500 Hz, meaning 500 cycles per bit in 1 second. For each cycle, we can give value from 0 to 255. When we give the number 0, it means that the pin will never be worth 5 volts, or the pin is always worth 0 volts. Where if we give a value of 255, then through the cycle it will be worth 5 volts, never 0 volts. Next one is duty cycle. Duty cycle is a representation of logic high condition in signal period and is expressed in terms of percentage in the range of 0% to 100%. For example, if the signal is in a continuous high condition, it means it has a duty cycle of 100%. If the high signal time is the same as the low state, the signal has a duty cycle of 50%. This is the duty cycle formula. This is the process of duty cycle. Thanks. That's all. And thank you for your attention.